Hello dear friends, this is an example of AES algorithm. So in the AES algorithm I have illustrated all of the transformations and states and the words transformations key expansion process in my previous slide. So in this lecture I will update the example of AES. So my plain text is 54, 77, 6F, 24, F, 6E, 65, 24 and so on, and my cipher key that is of 54, 68, 61, 74 and so on 75. So there are rounds and the pre-round transformation. In the pre-round transformation we have to perform only the add round key, and in the rounds we have to perform the four type of transformation. The first one is sub by, shift rows, mix columns and the add round key. So for better understanding I have created this diagram. So in this diagram there is a rounds, input state, output state and the round key. So for the input state, what is my input state? The input state is the plain text. So just put the plain text as it is, like this is the block level and this is a state level. So there is a application that you have to utilize block to state transformation. So how can we transform from block to state? This example is already illustrated in my previous lecture, so you can see it from there. So 54 will be put it here, then 77 here, 6F and 20, and 4F, 6E, 65 and 20. So column wise I have to fill it. Then just like the same way I have to fill out the cipher key, like 54, 68, 61 and 74 and so on, the round key generated. For the pre-round transformation, the cipher key will be act as a round key. For the round one key, how can we generate the another round key? That is already explained in my previous lecture. So you can see my key expansion process in my previous AES lecture slide. So I have to generate the output state for the pre-round transformation. So in the pre-round transformation we have to automate the task that is called add round key. Means we have to just add up the column, one column of the input state to the another column of the round key, addition of the two columns. So 54 have to be added with the 54, 77 has to be added with the 68, 6F will be added to the 61 and 20 will be added to the 74. So for the more detail I have made another diagram for the more clarification about the transformation. So there are four type of transformations: sub by, shift rows, mix columns, add round key. So in the pre-round transformation only the add round key is invoked, and pending remaining three will be in the inactive state. For the round one, all of the four transformations, sub by, shift rows and mix column, add round key will be performed. So because I am generating the output of only the pre-round transformation, we have to just invoke the add round key. So what is 54 and 54? That is 0 0, just put 0 0 as it is. Then another is 77 and 68. We have to perform the XOR operation of the binary digits. So what is 64 and 77 and 68? So how can we represent the value of 77? So for the example, 77 is the binary equivalent of 7 is 0 111 and 0 111, and the another one is 77 has to be added with 68. So what is the 68 equivalent? Equivalent of 68 will be binary equivalent of 6 is 0 110 and 8 is 1000. And what will be the XOR operation between these two? The XOR operation is 0 0 0 and 1 and 1 and 1 and 111. So what will be my outcome? That is 1 and F, 1F. So 1F will be put in here, 1 and F in the capital letters. So like in the same way I have to just add another digits like 6F and 61. So 6F here and 61. Please add decimal equivalent, binary equivalent 0 1 1 0, and F will be represented by 4 ones. Then 0 1 1 0, and 0 is represented by 0 0 0 and 1. What will be the equivalent XOR operation? 0 0 0 and 0, then 1, then 1, then 1 and 0. So that is 0 and E. So like in the same way, I have to represent all of the columns by using the XOR operation. And the last one is 20 and 74. So 20 and what will be the 74? So 0 is represented, 2 is represented by 0 0 1 0, and 0 is represented by 4 times 0. Now 7 is represented by 0 triple 1, and 4 is represented by 0 1 0 0. What will be the XOR operation? 0, it will be 1, then it will be 0, then it will be again 1, and it will be 0, then 1 and 0 0. So 0 1 0 1, that is 5, and this one is 4, so 54. So like the same way, I have to represent all of the columns by addition of two columns. One is from the input stage and another from the round key. Now you can see my add round key is generated. So my first transformation of the pre-round is completed, and this add round key will be act as an output state because there is only one transformation in the pre-round. So this will have to be copy and paste into the output state, and this output state will be act as an input for the next input state for the next round. So for the round 1, this will be act as a input state. So for the next round, what will be the first operation? The first operation is sum bytes. So in order to perform the sum bytes operation, we have to look up in the table. So how can we look up the table? I already discussed in my previous video lecture. So just for the revision, I have to tell you 2 to 3 digits. Just for the example, like 0 0, I have to look up 0 0 in the sum bytes table. So this sum bytes table is given to you if this type of question is arrived in the exam. So 0 0 is 52, so it is inverse sum bytes operation. Yeah, this one, it is 0 0, so answer is 63. So just put out 63 in the sum bytes transformation. This one, 63, simple. What will be the next one? The next one is 1F. So look out in the table. What is 1F? 1 and F, that is C0. So fill C0 here. So like in the same way, I have to fill all of the tables in the sum bytes columns by using that table, lookup the table. So now my lookup table is complete and my sum bytes transformation is over. Now this will be act as input for the next transformation, that is called shift rows. So what is the shift rows? According to the row numbers, we have to shift the bytes, and the row number will be start from the 0. So it will be act as a first row, 1, 2 and 3. So if it is a 0th row, then there will be no shifting, and this digits will be pasted as it is. Now it is a row 1, then we have to shift the bits by 1 position. So 2F will be here, 2F, 93, 92 and C0. Now this is a row 2. So for the row 2, we have to shift the bits by 2 positions. So AF and C7 here, and another one, that is AB and 30 here. Now it is a row 3rd, so we have to perform the shifting by 3 bit positions. So now A2 is here, and 20, CB, and another one is 2B. So it is very simple. My shift rows transformation is complete. Now I turn for the mixed column. So there's lot of confusion to the students that how to perform the mixed column transformation in the AES, because subites and the shift rows is very simple. Add round key, just you have to perform the addition. So how can we perform the mixed column? Because we have to multiply the constant matrix to my state, this one state. So there is a column matrix, constant column matrix is given to you, that is 2 3 1 1 1 2 3 1 1 1 2 3 and 3 1 1 2. So this table is given to you, that is a constant matrix that is already defined by the AES developers. So the reason why it is 2 3 1 1, it is not known to anyone, just we have to use this type of constant matrix in order to perform the diffusion, in order to include the diffusion in the AES algorithm. So my state is this one, shift rows after the state is this one, and my constant column matrix is this one. But here are some rules in order to perform the multiplication, because the digits are 1 2 and 3, means we have to perform the multiplication by the digits of the state with the 1 or 3 or 2. So how can we perform the multiplication? There is a specific procedure. So in order to perform this multiplication, there are certain things that I have to explain. That there are 3 digits in the constant matrix, that is 1 2 and 3. So if your digits in the state is multiplied by the 1, means 1 binary equivalent of 1 is 0 1, then the outcome will remain the same as this digit. As very usual thing, very common thing, that every digit if you multiply with a 1 bit, then the outcome will be remain as same. Now the second point is, if a digit is multiplied by 2, if your digit means hexadecimal digit, this one is called the hexadecimal numbers, if it is multiplied by 2 means 1 0, then digits have to be left shift by 1 bit. The digits have to be shift left bit by 1 bit. And the third point is, if the digit is multiplied by 3, which is the maximum number in your constant matrix, then you have to break out 3 into 2 parts. The first one is 1 and the second one is 2, because 3 is made up of 2 things. The first one is 1 and the second one is 2. So 3 1 1 in the binary equivalent is 1 1 will be break out into 2. 2 binary equivalent is 1 0 and another one is 1, the binary equivalent in 0 1, and you have to perform the multiplication with 2 XOR 1, like digits, your hexadecimal digits from the state matrix, multiplication with the 1 0 XOR 0 1, because it is 2 and it is 1. In the Galois field, all of the subtraction and the addition operations have to be considered with the equivalency of XOR operation. So 2 and 1 have to be performed in the XOR, and this XOR operation outcome will be multiplied by the digits. So for the example, first, in order to represent this column, I have to multiply the first row of the constant matrix with the first column of the input state of the shift rows operation. Means we have to perform 2 into 63 XOR operation. In normally you have to do the addition, but in the Galois field, this addition and subtraction operation will be considered as a XOR operation. So I have to take XOR, means 2 into 63 XOR 3 into 2f XOR 1 into AF XOR and 1 into A2 XOR. So this one I have to solve. So how can we solve this equation? Like 2 into 63, what is the rule? Second rule says, if the digit is multiplied 2, then digits will be left shift by 1 bit. So how can we solve this? This is your digit, that is 63 hexadecimal digit. It is multiplied by 2, then digits have to be shifted by left shift by 1 bit. So we have to perform the left shift. Just convert this 63 into the binary equivalent and perform the left shifting by 1 bit. Here I am performing, I already performed the left shift. Now jump into the second, that is 3 into 2f. So here the third case will be applicable, that 3 will be broken out into 2 parts, and the first one is 1 and the second one is 2. So this one, that is 2 1 0 and XOR 0 1 multiplied by the digits. 2f, the binary equivalent of 2f is this one. 2 will be represented by 0 0 1 0 and f is represented by 1 1 1. Like the same way, digit is multiplied by 1 0 XOR 0 1. So 10 XOR 01 is multiplied by the digits. By distributive law, we have to distribute this equation, like 10 will be multiplied by this digit, XOR 01 will be multiplied by this digits. So here it automatically invokes the first and second point, that the digit is multiplied by two number. So if the digit is multiplied by 2, then we have to perform the left shift operation. So I already performed the left shift operation here. And the another one is, if the digit is multiplied by 1, then the outcome will be same as the previous digit. So this one will be the outcome after performing the multiplication operation with the 0 1, and then we have to perform the XOR between the two, and the outcome will be 0 1 1 and 0 0 0 1. Now another one is, that is 1 into AF. This is very simple. The first point will be invoked. If the digit is multiplied by 1, then the outcome will be remain same as the same digit. So AF will be act as a AF, and the binary equivalent of A is 1010 and F is 1111. Now 1 into A2. So again the same point, the first point will be invoked, the same digit will become the outcome. Now this whole part have to be XORed, because I am distributed, I calculated these values in the distributive nature, like this one first, this one first, this one second, and so on. Then I have to perform the XOR operation between of them. So just perform the XOR operation, like the first value, second value, third value, and fourth value, and after performing the XOR operation, the outcome is BA. So 1011 is B and 1010 is A. So now we can understand the first block of the mixed column will be BA. Like the same way, you have to perform the another multiplication with the constant matrix, and you have to fill out all of the columns. So now I already filled all of the columns in order to perform the mixed column transformation, in which I have to multiply with the constant column matrix. Now the last operation of the round one is add a round key. It is very simple, just you have to perform the addition with the round key. So what is the first value? BA, and the round key value is E2 here. So we have to perform the addition between BA and E2. BA, what is the equivalent number? That is 1011 and 1010. BA and E2. That is 1010 and 0010. Perform the XOR operation between the two. The outcome will be 0 0 0 0 1 1 0 0 0. So it will be 1 and 8. I think it is not A2. It is, yes, it is E2. What will be the equivalent decimal value, binary value? That is 10 and 0. Now it is 0, it is 1, it is 0, and it is 1. So it is 5 and 8. So like the same way, I have to perform the add round key for all of the values. Like next value will be XORed 75 and 32. So it is very simple. So I already performed all of the transformations, and my round one is complete, and my answer will be the last transformation, that is add round key. So this will be act as an output state for my round 1, and this will be act as an input for my next round, that is round 2. So like the same way, it is very simple. You have to perform the transformations and find the outcome of all the rounds. So it is just for the basic understanding that how the AES works in more detail by using this diagram. I hope it will more clear to all of the students now. If anyone has a doubt, kindly mail me. So be ready for the next topic. The next topic will be the key management that I will elaborate you. So keep safe and thank you.